Imagine you're in an ancient marketplace, thousands of years ago. There's no barcode, no calculator, not even standardized numbers like we use today. Just traders, counting goods by hand. A farmer walks in with eggs. A merchant wants to buy them. But here's the problem. Counting one by one is slow, and mistakes mean loss of money. So people needed a smarter system. Instead of counting 1, 2, 3, they started grouping. Now here's where it gets interesting. Early civilizations like the Babylonians didn't use base 10 like we do today. They used a base 60 system. Why? Because 60 is incredibly flexible. It can be divided by 2, 3, 4, 5, 6, and more. That made trade, measurement, and calculations much easier. And from that mindset came a powerful idea. Numbers that divide easily are useful. Now here's the key part. 12 isn't just any number. It's what mathematicians call a composite number, and even more importantly, a highly composite number. Before we move ahead, let's quickly understand what that means. A composite number is any number that can be divided into smaller whole numbers, apart from 1 and itself. For example, 6 is composite because it can be divided into 2 times 3. But numbers like 7 are called prime numbers because they can't be broken down like that. Now coming back, 12 isn't just composite, it's highly composite. That means, compared to any smaller number, 12 has more divisors than all of them. Let's look at it. 12 can be divided by 1, 2, 3, 4, 6, and 12. No number before 12 has this many clean divisions, and that's exactly why it stood out to ancient traders. So instead of grouping items in tens, people often group them in 12s. Why 12? Because 12 can be divided into 2, 3, 4, and 6 equal parts. That means if you're selling something, eggs, bread, fruits, you can split them easily among customers without leftovers. Try doing that with 10. It doesn't work nearly as smoothly. Now picture a merchant selling eggs. If he packs them in groups of 12, he can sell half a dozen, 6, a third, 4, or a quarter, 3. All clean divisions, no fractions, no confusion. Over time, this became standard practice. In medieval Europe, this idea spread even further. Markets, trade guilds, and even laws started adopting 12 as a convenient unit. Bakers sold bread in dozens. Traders sold goods in dozens. In fact, there was something called a baker's dozen, which was 13 instead of 12. Why? Because bakers were afraid of punishment for underweight bread, so they added 1 extra just to be safe. But still, the base number remained 12. What's fascinating is that this wasn't just about convenience. It slowly became tradition. Generations grew up buying and selling in dozens, so the system became deeply rooted in everyday life. Even when newer number systems and modern counting methods emerged, people didn't feel the need to change something that already worked so well. Traders trusted it, customers understood it, and it made transactions smoother without any extra thinking. Over time, the dozen stopped being just a practical grouping and became a cultural habit, something so familiar that we still use it today without even questioning why. Even today, you can see the legacy of this system everywhere: 12 hours on a clock, 12 months in a year, and 12 inches in a foot. This wasn't random. It all comes from the same idea. 12 is practical. So, after thousands of years of trade, math, and human habit, the dozen stuck. Not because someone randomly chose it, but because 12 quietly turned out to be one of the most useful and mathematically special numbers humans ever used. And that's why a dozen equals 12. For more fascinating stories where everyday things reveal hidden science and history, make sure you subscribe and stay curious, because there's always more than what meets the eye, only on Curiosity Compass.